Good afternoon, ladies and gentlemen. Thank you for attending our August 27th Improving Talk. Summer is coming to a close, but Improving is here, delivering the hottest webinars of tech. And today's webinar is guaranteed to turn up the heat on your IT skills, fire up your creativity for using AI, and leave your mind sizzling with new ideas of tech. Now, before we begin, I'd like to inform you about a feature in the presentation that will enhance this session's interactivity. Please note the Q&A icon on the presentation screen. Clicking on that icon will open the question and answer feature, which allows you to send the moderator questions to be delivered to our insightful presenter at the appropriate time. And speaking of insightful presenters, I'm thrilled to welcome Scott Poulin as our speaker today. And Scott is not making you sweat during his on-fire webinars. He serves as one of Improving's hottest vice presidents of technology and has been working in software and the AI space for over 17 years. Not impressed yet? Scott also has a degree in physics, specializing in quantum theory and computing. I particularly find that amazing because I had always thought that was a term simply made up for comic books like adamantium and kryptonite. Today, Scott will be sharing a talk titled The Executive Playbook on Integrating Bleeding Edge Tech. Scott, the floor is all yours.
Thank you. Appreciate the warm welcome. Thanks everyone for coming to see me talk today. We're going to talk today about harnessing leading edge technologies. And this is just effectively our executive kind of playbook about how to go do this. And then we'll jump right into it. So skip on the introductions. Scott already covered this. Nothing really to add here. Been in a bunch of industries other than that. But yeah, we'll jump right into it. So today, here's our roadmap for today's presentation. We'll start by discussing why the edge and why now, essentially looking at the driving forces behind adopting bleeding edge technologies today and how to balance speed versus safety. Next, I'll give you the playbook at a glance, an overview of our framework. We'll then break down the edge ops pipeline step by step, starting with how do we discover, vet new technologies, our new tech ideas, how to evaluate them, run pilot projects, scale to successful ideas, operate them long term, and then continuous feedback and learning loops. Along the way, we'll explore how to map signal to value, turning tech signals into concrete business outcomes, and how to implement dual speed governance, which lets us innovate quickly in a sandbox mode while maintaining control in production. We'll talk about managing investment portfolio for innovation with stage gates, effectively a venture-style approach to funding these projects. And finally, lay out a 90-day action plan so that you have a practical next steps to take after this session. Then we'll wrap up with some Q&A at the end. One quick thing to mention is that a couple things that we won't mention in this presentation, but are key to kind of call out. Change ready culture. This is things that are typically involved in this kind of additional aspects of the playbook. Executive dashboards, example KPIs. We'll go through some of that aspect, but not in depth. But if you take our workshop, we do go into depth on how to effectively utilize that. So we'll jump right into it. Why now? Speed versus safety. So why focus on bleeding edge technology now, or just in general? It comes down to a tension between speed and safety. On forces driving speed side, the half-life of technology is collapsing. The new advancements, think AI agents, generative AI, synthetic data, edge computing, privacy tech, you name it, are emerging at a insanely fast pace. Our competitors are shipping good enough solutions faster than ever, getting first mover advantages, you name it. There's a bunch of different groups of how a lot of this is being implemented. At the same time, regulations are getting stricter and boards are demanding real ROI, not just endless pilots. I think there was a research term that came out the other day that 95% of pilots are failing in the AI space and just in general. On the other side, the constraint is that many organizations still use legacy processes like quarterly release cycles or heavy governance gates that just can't keep up with the weekly or even daily iteration loops from frontier technologies thrive on. This gap between rapid and hype cycle velocity of new tech and slower enterprise change velocity is essentially lost value. Every extra month we take to implement a promising tech is opportunity or value we're missing out on. Our thesis is that you don't have to choose between fast and staying safe. Instead, you can move at a dual speed, placing measured bets. In other words, run fast where you safely can, in controlled experiments in sandbox, and apply governance in parallel to ensure safety. By operating at two speeds, we can innovate quickly without being reckless. It's like having a sports car and brakes that work together. Then faster you go, the more that you need good brakes. So the question becomes, how do we structure an organization to enable the dual speed approach? And that's what this playbook effectively is going to address. So it breaks down to this aspect of this path or road that you go down. And we like to break it into this effective aspects of a race car track in the sense that you need the fuel to go and the guardrails to keep you safe and make sure that you follow that aspect. So on the fuel side, the playbook emphasizes real-time KPIs and stage gate funding. This means every experiment or initiative must be tied to 2 to 4 measurable metrics. This is typically done in AI, quantum, you name it. For example, revenue lift, cost avoidance, risk reduction, or customer experience improvement. We're not innovating for innovation's sake, we're linking it to quantifiable business outcomes. And rather than giving a big lump sum of budget up front, we're using stage gate funding. We release funding in tranches. Only when the project clears certain gates or checkpoints do we get actual additional funding. As we like to say, we don't fund technology, we fund gates. In practice, this means money flows only as the project meets defined value and risk criteria at each stage. This venture-style approach ensures we invest more in things that prove their worth and cut things off that don't. Now, the guardrails, we have rigorous security and data privacy policies, for instance, in a lot of different clients of ours. Things like using least privileged access, defaulting to synthetic or anonymized data for testing, keeping a prompt or model registry for AI models, and maintaining audit trails. Compliance is baked in, and if a project deals with sensitive data or falls under regulations, we do things like data protection impact analysis, document model cards. Model cards are just effectively a way to understand what an AI model's intended use or limitations are. But additionally, we run red team tests to probe weaknesses and ensure there's a kill switch or rollback plan if something goes wrong. We also have financial controls, for example. We cap the value at risk for each pilot, meaning there's a maximum potential loss or investment we are willing to risk on an experiment and require a basic unit economics model and target playback period for projects. Finally, we have the concept of a fusion team, a cross-functional team that comprises of all the key roles, product engineering, technologists, effectively meaning an expert in like AI, ML, quantum, any of the kind of topics that we've talked about in this series, that specialist who understands that dynamic of that new technology. Security and privacy, finance, operations, domain SMEs, and change management. All of these teams work together as a dedicated team to effectively start to finish on any sort of project. Together, these fuel elements and guardrails create an environment where innovation can thrive, but within boundaries. Effectively saying, experience must show real metrics, get funds only when it hits targets, and must follow strict safety rules. If they do, we double down. If not, we stop. Governance here is meant to be a brake that slows us down. It's more like a guardrail that lets us drive fast without flying off the cliff, effectively. So, what do each one of those steps effectively look like? We'll start with the discover. So, looking at this is the first stage. Effectively, the objective in discover is to convert weak signals into testable outcome linked hypotheses. A signal could be anything suggesting a new technology, a buzzword that's trying to get an industry, a competitor making a move, a new regulation, pain point by customers, you name it. Inputs to this at this stage, we pull in a lot of input sources or company strategies and OKRs to ensure alignments with big picture goals, known customer pain points, any shifts in regulatory environments, moves by competitors, briefing vendors or analysis, you name it. All of these help us identify where a bleeding edge tech might fit. So what activities occur in here? Well, we do fast, broad research and key activities include mapping signals to use cases using a signal to value canvas. More on that soon. Basically translating that tech trends or signal into a concrete hypothesis that could deliver a business outcome. Conducting quick problem interviews or desk research to validate that need. For example, if the signal is an AI and customer support, we might quickly interview a support manager or check how big a pain point first tier support is. That way there's actually valid reasoning behind what you're doing. Checking data availability and governance. If the ideal idea data, do we have it? And then can we use it? Are there privacy concerns or contracts that limit use, etc.? Also, maybe doing a 1 to 2 day technical spike, a mini prototype or a hello world, quote unquote, with the tech just to see if it basically works in our context. Brainstorming a risk register at an early stage, listing out obvious risks like privacy issues, safety or ethical concerns, potential IP leaks, vendor risk, you name it. Brainstorming mitigations up front just to make life easier. Outputs of this aspect is by the end of discovery, we want to make sure we have a short list of more promising 3 to 5 ideas out of the perhaps many initial signals. For each of these top candidates will have a rough VMR score, which is the value maturity readiness score. We'll explain that here at the end of the link of this. So there's a section specifically on it. Effectively, as an identified owner for an idea or a time box, ideal budget, essentially we're saying here are a few hypotheses worth testing, along with what we need to test them. And then the guardrails here, even at this exploratory stage, we impose some guardrails. We don't typically use raw production data in experiments. We use typically synthetic or anonymized data to explore, working in sandbox, isolated for any like real customers, a live system to avoid any potential impact. This just kind of keeps our risk very low during these quick investigations. Time box, about 5 to 10 business days, 1 to 2 weeks. This forces the team to keep a broad scope but shallow depth, cover a lot of ground quickly without getting bogged down. The idea is not to really fully prove each concept yet, just to evaluate and have to pick the best ones. We also encourage the team to kill or merge lookalike ideas early to make sure that two teams aren't trying to discover similar solutions and combine them. It's better to rather combine them rather than duplicating work effectively. The roles here, it's product owner is accountable typically in this sense. Engineering lead and domain expert are responsible for research and executing prototypes. People that we typically keep involved or informed is like legal and ops and maybe other individuals in case they see potential red flags. And then we have additionally our security and finance like individuals available to advise on feasibility and risk just from that standpoint, more as like a sanity check. In summary, the discovery phase is like a funnel. Take a wide array of inputs, filters, and shape them into solid hypotheses that are worth taking a closer look. We want to we want to do enough due diligence to say these ideas seem viable and valuable. Let's evaluate them further, which leads us into the next phase, evaluate. After discover, we move into evaluate. The objective here is to decide whether to go, hold, or kill an idea at gate 0 and to do with both effectively efficiency. Think of the evaluate as a 5-day due diligence sprint where we deep dive enough into making informed decisions on those few ideas from the discover. So what happens in this 5-day diligence sprint? Effectively, there's this outcome of hypotheses and KPI models, technical maturity scan. Effectively, this is how mature is the technology? Is this tech proven or experimental? What is its kind of understanding of where it fits today? Is there some sort of security posture or pen test that needs to be performed on such tech? Organizational data readiness, and then TCO and exit. So total cost of ownership and exit. We consider total cost of ownership and what an exit or scale down strategy would be in this sense as well. For instance, where are the ongoing costs if this scales, and if does this work out and can we pull out easy, or will we be stuck with some cost or vendor lock-in? This includes checking the vendor's viability. Are they a stable company, and ensuring we're not solely dependent on a tech we can't support within our client or that client can support specifically. Looking at risk registers and mitigations, just really brainstorming this aspect of what risks are there, and then kind of continuing on. Now, gate 0 is the effective decision point. We set gate 0 criteria that must be met for the project to go. This is essentially a checklist. A clear KPI and outcome hypothesis must be defined. We need to know what we're effectively measuring that effectively results in our success. The expected net present value of the project or some value metric, which should be a minimum threshold we should consider worthwhile. This typically includes a payback period and understanding as the total cost versus how much potential revenue that is effectively come from it. Is the data path feasible if it's a data related project, or is some sort of aspect data is required to perform some sort of validation on your thesis? Is that available? Project sponsor, just having an executive champion is very key in this sense to help make sure that you have solid funding throughout the rest of your gates. Value at risk is this is meaning the maximum budget or risk exposure is under a set of limits so we're not betting the farm on effectively a pilot. And then an exit plan is identified if you have to unwind the project or switch solutions. We have an idea to do that. For example, avoid lock-in by making sure that we can export data or turn off the feature without major disruptions. Additionally, this effectively allows us to put in place a system that allows us to move effectively through this aspect. And so, if all of those criteria are met or will be met by the time the pilot starts, we give a go for the project to proceed to the pilot phase. If some are not met, then we might put the project on hold, giving the team time to address the gaps, maybe get a sponsor or adjust the scope. Or if they discover major issues like it doesn't make sense financially or the technology is just not ready, we kill the project right then and there. Even if we kill the project, we document a one paragraph lesson learned on the knowledge that isn't lost. So that way, if you come back to it, you understand as to what you've already performed and where the gaps are. Continue down that research at a later date. By the end of the evaluate, we should have a clear yes on a few initiatives, and then we are ready to move into an experiment, which brings us to pilot. Now, the fun part. The pilot is effectively the objective of this pilot phase is to generate validated learning from a small blast with a small blast radius. In other words, run a real world experiment on a limited scale to prove or disprove our hypothesis while containing risk. There are design principles for a pilot. We deliberately keep the pilot for small and safe, keep as small and safe as possible. We might throttle traffic to a new solution at, let's say, 5 to 10% of most of the users, or just use some sort of human in the loop for oversight aspects. There are typically audit and trails for monitoring that are put in place on day one to make sure that no kind of guardrail violations happen on an iteration aspect, looking at both latency, response time, understanding the quality of the results, all that. And then we design architecture to be reversible. We plan to make sure that we roll it back or turn it off quickly if needed, which effectively helps with the sense of setting kind of this kill criteria up front. It puts conditions under which we can terminate the pilot early. So controls of tools. We also want to support the above with various types of tools, maintaining a prompt or model registry, evaluation harness, privacy filters or redaction, and observability aspects. And then time box and funding. A pilot should typically take 4 to 8 weeks. We intentionally limit the time. If it drags on longer, it might be an indication that we're not executing tightly or the scope wasn't small enough. Funding wise, we only allocate tranche one funding. This is initial budget that we approve at gate 0 to run the pilot. The next chunk of funding would only be released if the pilot meets success criteria gate 2. That way, if the pilot fails, we've only spent the small investment effectively. Success gates examples, we define clear quantifiable success criteria that we'll check at the end of the pilot. Effectively, gate 2 is checking for these. For example, say our pilot is an AI support agent, we might get a success gate of at least 25% deflection of support tickets and at least 95% customer satisfaction on those interactions. Both conditions have to be met to call it a success. That might have other thresholds like guardrail violations less than or equal to 0.3%, ensuring that AI only rarely makes mistakes outside of the allowed bounds. And performance like 95% of the responses are under 1.5 seconds of latency, something like that. Additionally, a business metric as such should have been in play to, if we continue, the payback period would be under 12 months and understand that. And that comes from all the different evaluations from the finance aspects of it. So this ensures the pilot isn't just technically working, but also adding value, controlling risk as expected. Those gates are met, great. It's a strong signal to scale. If not, that's okay. It means either kill the project or perhaps pivot and redesign and maybe come back for another pilot iteration. The team must be prepared that a no-go at gate two is a valid, even successful outcome in the sense that we learn that what doesn't work. And so I think that's kind of adding to the high scale of where we're seeing in the news for like AI agents and or AI solutions. People are saying that 95% aren't working. This is part of that aspect. Technically, it's a successful outcome. Yes, it didn't turn out to be working, but it's still a successful outcome out of that. Regardless, in summary, the pilot is about testing in the real world at small scale. We're optimizing for insight, not for scale at this point. We want to answer, did this idea actually deliver the expected value? What did we learn? Can it be safe and effective to do bigger? One important practice, whether a pilot succeeds or fails, the team will publish a short memo documenting these results. Just goes back to the aspect of how do we understand what we have done in the past and how do we make sure that we don't do it again in the future. It typically outlines why we killed it and what we learned. This way, the knowledge is captured and shared, avoiding innovation theater, which we'll talk about later. It's a very common aspect that happens today, I think, in large organizations, but it just reinforcing a culture that it's okay to have pilots that don't move forward as long as we learn from them. So, jumping into the scale aspects. Suppose our pilots clears its success gates. Great. Now we move to scale, which means taking the solution and rolling it out broadly into production in a responsible way. The objective is to harden the solution and deploy it enterprise wide or to all users while ensuring we maintain reliability and control risks. Before we hit the big red go live button, there are a few preconditions that correspond to gate three, the gate pilot and full scale, the gate between pilot and full scale. We treat gate three almost like a launch readiness review. Some key things that we want to see: SLOs defined and met, DR and business continuity plans ready, on call and runbooks in place, data contracts and lineage, change management and training, procurement and legal complete, cost modeling evaluated. All of those are preconditions that satisfy. If those preconditions are satisfied, gate three is effectively go for launch. We proceed to roll out. We do this carefully with using proven rollout patterns to minimize risk. When we might start with a canary release, a green blue deployment, feature flags, a rollout to stage geographies or segments, you name it. During scale and immediate immediately after full rollout, we kind of keep an eye on key metrics that we need to watch to ensure everything is going as expected. We monitor with our SLL service levels are being met at a broad scale. Are we still achieving like 99% uptime or response times as promised? Change failure rate, basically the percentage of changes or deployments that cause a problem. We want that to stay slow, indicating our deployment process is solid. Other features like our other metrics like human override rate, unit cost trajectory, realized run rate benefit, a number of different things. So effectively, we treat scale as a launch of a big deal, but almost like a product go-to-market launch, not just an IT deployment. You want it to actually feel like it means something. This typically means that you have to coordinate with stakeholders, communicate the successes, be prepared to celebrate it, or troubleshoot it intensely in early days. By gate three, it's not just the tech is ready, it's the business is ready to integrate with the tech fully. If it goes well, the project graduates into the last phase, which is operate. Once the solution is fully scaled and in production, we're at the operate phase. This objective is to sustain the value we've created, keep it under control, keep risks under control, and continuously improve the system over its life. Typically, we have things like run practices. We adopt robust operational practice, much like any mission critical system, with a few specific focuses given that this is a formerly bleeding edge project. This typically is continued with security practices like regular access reviews, making sure only the right people and systems have access to the data and code, rotate secret keys, you name it. We pay close attention to cost observability, so like the FinOps aspects, making sure that our project when the project is running, it stays cost effective. We're not blowing up our cloud costs or any licensing costs. And then there's a bunch of different aspects like KPIs to monitor and operate. We treat these as like running a business service. So some of the key metrics we typically look at in this is run rate benefit, cumulative net present value versus the plan, incident rate versus severity. Effectively, this is how often are there incidents and how severe are they? Ideally, this stays low and improves the system as the system matures effectively. Guardrail violations per X number of operations, just understanding as to how often is the solution operating outside of its guardrails and how we typically want this to be extremely low, and typically they are. Drift metrics, audit coverage, you name it. So keeping all of these in effectively an operational dashboard is kind of a key practice. This means that we report the good and the bad. Maybe the new system saves $2 million a year, great, but it also had 3 serious outages, not great. Both need to be visible so that we can weigh the decisions effectively. By doing so, we maintain trust and make data-driven decisions on whether to continue to expand and adjust things in production. So the final piece of the EdgeOps pipeline is feedback and learning. This is depicted as a closing the loop, feeding the insights from each project back into our active portfolio and our organization's capabilities. Just because a project has moved to operate or was killed early, it doesn't mean the story is over. We want to learn from every outcome and continuous improvement continues to improve our innovation process. The biggest objective here is make sure outcomes, success, or failure of each initiative inform our future decisions and skill building. We want a culture of constant learning effectively. Within inside of that, there's a bunch of different aspects of like win or kill memos, just effectively what we learned in the project itself, but just a brief on that aspect. Ongoing intake and triage cadence. Every week, you typically still accept new ideas and do a triage, understanding the aspects and going through that discover and evaluate. This is just allows for new ideas to come in and test out different types of POCs and all that. Typically, there's a monthly portfolio review, which we touched on a little earlier, to look at ongoing and completed initiatives together. And quarterly, we rebalance and mix those projects and understand as to how many Horizon 1 versus Horizon 3 projects we're doing based on the results and changes in strategy. And we'll talk about Horizon 1 and 2 and 3 here in a bit. We also create telemetry-driven backlogs for capability improvements. What this means is, well, from all these pilots and operations, we gather telemetry data about where we struggled. For example, if multiple teams had issues with data quality and maybe we need a better data platform, and that goes into our capability improvement backlog. If we notice a certain risk kept cropping up and we might invest in a tool or a training to handle it better. Essentially, the process itself is improved via observation. We maintain knowledge base on top of that, typically, and update any playbooks themselves as well to make sure that we stay aligned with any culture of our clients or with inside of the aspect of what makes sense for them. In addition, if we learned new heuristics, say a new factor to consider in the VRM scoring or a better way to run, that is also kind of indicated in this step as well. So,
Scott, we have a question.
Yeah, definitely.
Melissa's asking, ideally, which gate or step is the future ops owner identified? Is it always at discovery or can it be later?
It can be later, but there should be kind of an initial individual that kind of champions it, if that makes sense. It's kind of, there's a couple different ways to effectively do it. But yeah, hopefully that answers the question. Jumping into it, the EdgeOps pipeline operating models. This is just, we've talked about the stages of aspects of EdgeOps. And now we want to look at it as it shows from an operating model standpoint and how this pipeline runs continuously in any organization. So imagine funnel and assembly line is constantly moving ideas through different stages and regular checkpoints. So we have our intake, we have ongoing intake processes where ideas or signals come in. We might have a simple form or a template people build that frames the idea, problem statement, or that frames the idea. So like a problem statement, a KPI, a rough value hypothesis, or data needs. If an idea doesn't name a KPI in a dollar hypothesis, it doesn't enter the system type thing. So we enforce the discipline of this. We also try to acknowledge new submissions, or we recommend to acknowledge new submissions within 24 to 48 hours, so folks know that it's being looked at. Otherwise, they won't commit to it or add to it. The output of intake is a ready for triage card for each idea, like kind of like a summarized canvas, understanding as to is this actually something that has gumption to it versus just having a sentence idea, right? So then we go through kind of a weekly triage on a regular schedule, weekly or bi-weekly. The cross-functional council effectively meets to triage new ideas. They rank them using the VMR framework, which we'll cover next, actually. And overall fit and alignment. They decide which ones to move into evaluate gate zero diligence next, and then assign teams for that, in which to hold or drop. Decisions might be product lead is accountable, engineering and finance are responsible, and scoring, and security council is effectively consulted. This ensures we're always picking the best next bets. Also at triage, we might merge similar ideas and keep the backlog tidy, just kind of as what we mentioned prior. So at gate zero and pilot execution, then those ideas go through the 5-day diligence of gate zero meeting, could be part of the same weekly meeting or separate. If approved, they become pilots, and we may schedule multiple pilots in parallel and resources. So effectively kind of going through all of the aspects of what we've already discussed today and in that framework per se. So the operating rhythm, the pipeline thus runs continuously. Any week, new ideas may be coming in. Some ideas might be evaluated. A couple pilots might be running, and some scaling efforts might be going on. It's not strictly sequential, it's concurrent like an innovation factory. Time to decision targets. We set targets for efficiency. For example, time from idea submission to gate zero decision is less than or equal to 10 business days, or pilot is less than or equal to 8 weeks, as previously mentioned. Kill rate target, perhaps 30 to 50% of pilots. If we kill less, maybe we're not taking enough risk, or we kill much more, maybe our intake filter is too low. So really setting understanding as to what that kill rate target is and what that means for us. And then WIP limits to ensure quality focus as well. And then governance and transparency. Everything is tracked. We have an exec dashboard, perhaps with all the pilots and their status, KPI performance, next decision date. So effectively everyone, especially stakeholders like CFOs, CIOs, understand what's happening. In summary, the operating model ensures edge ops pipelines isn't ad hoc. It's a repeatable process with roles, meetings, metrics, and it just keeps going along, and they're understanding as to where it is. It becomes a functional part of your business. This makes innovation a managed endeavor, not just a random brainstorming aspect. So the framework, the value maturity readiness framework. So we mentioned this early. It's just a framework that we typically like to use as kind of a back in the hand evaluation. We score each idea on 3 dimensions: value, how much potential value could this bring if it pans out. This includes tangible business value like revenue increase, cost savings, risk reduction, or improved customer satisfaction. The maturity here is the M side of it, that how mature is the underlying technology or approach. High maturity score like 5 means that the tech is well proven, perhaps already in use elsewhere, likely to work as expected. Lower technical risk aspects versus a low score 1 means it's very experimental or unproven. We might be among the first to try it or in its alpha tech. So we consider things like security stability here. This is weighted somewhat less than maybe 30% of the actual calculation. We take some risk. Tech risk is a value if the value is high, but obviously more mature ideas are safer bets. And then R for the readiness aspect, how ready are our organizations and the environment to execute on this idea. High readiness means we would have the data readily available, the team with the necessary skills, it fits within a current strategic initiative, and we have buy-in, no major external dependencies are missing. And a low readiness would mean that lack of important capabilities, like do we have to hire someone or do we have to partner with somebody? Are there huge data hurdles? Do we have business sponsor yet? So Typically, the readiness aspect is weighted about maybe 20% comparative into the other aspects of the formula. And I didn't mention this, value is typically weighted at 50%, just because of the idea if it doesn't on a significant value, it's not worth really chasing if it's easy, if that makes sense. So typically this comes out to a normalized function that allows us to calculate, and everything is scaled on a 1 to 5 ratio, just allowing us to make an assumption or compute a weighted score to understand as to where does this fit. That being said, VMR is not an oracle. It's just more of a tool to help compare diverse ideas on a common ground. It helps remove some bias, the coolness, quote unquote, of a tech or the hype of that tech. It forces consideration of practical aspects like readiness, even in brainstorming aspects. Which brings us also into another tool that's typically used is understanding the foundational shift versus the fleeting trend. With many new tech signals, a big question is this a real foundational shift we must jump on, or is it a fleeting trend that will effectively fizzle out? I think we can kind of all call out things that we have seen in that sense, where comparative to AI, where we know it's a foundational shift, versus I think this is a debatable aspect, but blockchain was probably one of those realms where it's not necessarily in a foundational shift aspect, but more of a fleeting trend. We'll see if that circles back and changes. But based off of how the effective like world has gone and utilized blockchain at scale, it's become less of a foundational shift and more of a fleeting trend. That being said, foundational signals tend to have a number of different characteristics. They represent a durable shift in cost or capability curves. For example, AI language models recently made a huge foundational jump. Suddenly, certain tasks are 10x cheaper or faster. This is not a one-time gimmick. It resets what's effectively what is possible. They gather developer mindshare and ecosystem. If you have a technology that's lots of serious developers and companies are rallying around, lots of GitHub commits, conference talks, startups formed, it solves a real problem that it's worth sticking with. There's a regulatory clarity of movement forming around it. Oddly enough, if regulators bother to start crafting rules, it means it believes that it's here to stay. As for like drones, AI, you name it, it has a platform potential. It enables other applications, meaning it's not just a single use case tool, but it becomes part of a standard stack. In contrast, fleeting signals, they often very demo friendly but hard to implement robustly. They look cool in a conference keynote, but and nobody can get them in a stable production. Have brittle tools or lack of support, open source projects with one maintainer or startup that hasn't ironed out edge cases, you name it. There's no clear path to compliance or scale. Cool facial recognition app, but obviously violates privacy laws and no way around it. Effectively, like a fad or a contact that it could be used illegally, or no contact that it can't be used legally. High integration tax, effectively to adopt it you'd have to rip out or rebuild a bunch of other things, so it becomes kind of impractical. Those tend to not be adopted very widely, and thus the tech might fade. A handy heuristic there's a handy heuristic here: remove the tech if the business outcome still has other ways to be achieved, then that tech might not be a trend. If removing the tech collapses the outcome, it means the tech is truly foundational. In other words, are we excited about this because it's the only way to get a particular big outcome, or are we excited because it's novel, but in truth we could achieve the same with existing means? If the latter, it's likely a fleeting hype. In the former, the outcome was previously unattainable and the tech unlocks it, then it's likely a foundational shift to pursue seriously. This heuristic helps us kind of filter the noise. For example, a few years back, chatbots were super hyped, but you could only then achieve the same customer service outcomes with a well-designed FAQ or app. The bot itself wasn't magic. There was partly a fleeting fad until AI improved how to handle things better and effectively put out the large language model aspects, which now have become foundational. So, scanning signals, we can try to identify those fundamental challenges like cloud computing was, or mobile, or currently generative AI, versus those are fashionable buzzwords that won't root. We allocate more attention to the foundational shifts. So, additionally, one thing I like showing here as well is just kind of aimed back at to the evaluate 5-day sprint, the lightweight due diligence. This is just kind of an assessment that helps with that as well, brings all the kind of things that we talked about in beforehand to kind of have an understanding of the output to help us make decisions a little bit more quickly. Additionally, this is stuff that is used to feed into your board or executive dashboard that you put in place to make sure that a lot of this stuff is moving forward effectively. And then, so signal to value mapping, real quick. This just introduces the map or the canvas that we typically do in Discover to structure our thinking, to understand the aspects of it. The goal is to take a raw signal like AI image generation is trending or a customer complains about wait times and turn it into a concrete use case with an outcome and metrics. The process here is effectively list signals, translate to use cases, define hard metrics. The canvas just ensures every idea has a clear business outcome hypothesis. If we think we can achieve X improvement on something, and then at least one hard metric is attached so we can test it, a line of sight from the tech to the value as well. Signal the new tech, use case applying the tech, and then value category aspects. The big thing here is don't start with features, start with outcomes and a small KPI. This is kind of one of those key foundational aspects that we learned from implementing machine learning and AI solutions to effectively getting to this point. So we often literally fill out a one-page canvas table for each idea, effectively a signal, the proposed use case with a brief description about it, the value category, if it's a revenue, generated cost reduction, etc. Success metrics, things about that use case that are KPIs that need to be about for that use case. And then by doing this, we ensure idealization is business driven, not tech driven. It prevents per tech projects that aren't tied to measurable business benefit effectively. Here are just a bunch of examples of other KPIs to effectively look at. I won't read through all of them, but some of the ones that we've seen are cost avoidance and then revenue width. Those are the kind of top two that I typically look at, but just depending on your business and what you're doing, there's a couple other aspects as well to consider. And then here, this is just kind of a real quick use case illustrating the signal to value with designing a pilot. So, for example, in the use case, an AI agent for tier one support, outcome hypothesis deflect 30% of tier one tickets, which results in X cost avoided per quarter plus performance metrics like latency less than 1.5 or 2 seconds, a violation rate of 0.3% around the model and what it's doing around the guardrails. So the experiment design, understanding the scope, the guardrails and success criteria, and the aspects of signal, likely advances in conversational AI plus high volume of L1 support signals, L1 support tickets are signals, the use case and hypothesis, outcome and value. So just really kind of putting in place all of these different things and looking at how do all of these drive the next aspects for the experiment and looking at the scope of the pilot, what are we going to do? So like the top 3 issue types like password resets or order status or basic FAQs, routing only 10% of the incoming chats through a bot initially that would answer that, and then put guardrails around it, making sure that there's PII guard redaction if there is any of that, prompt logs, make sure that is secure, and then agent transfer. So in the event that the chatbot can't actually answer something, they're transferred to an agent to actually help them to make sure that they have positive interactions. And then establishing that success gate, right? And so from here, we look at the investment portfolio for disruption. So H1, H2, H3, the Horizon 1, Horizon 2, Horizon 3. This just kind of explains the strategic level and treat our innovation initiatives as a portfolio to kind of akin to venture investing. So with the 3 horizons of innovation, H1, the core improvements short term, these are often incremental innovations to existing processes and products like automation and current ops, lower risk, a lower reward typically, but can keep the core business healthy. H2, this is adjacent or emerging opportunities, medium term, let's say like one to 2 years. These could become new lines of business or major improvements, but not totally change who we are. And then H3 Horizon 3 are effectively moonshots or disruptive ideas that could yield new business models or major shifts in 3 to 5 years. We typically take a 70-20-10 allocation guideline 70% of our resources are in H1, 20 in H2, 10 is H3. This kind of helps ensure that investment in the future is not as expensive, but we invest in the future, but not at the expense of the present, effectively. This just really breaks down into the aspects of different styles of venture style stage gates, like funding with VCs would do for various different companies, staggering funding across this as well. So risk budgeting. Additionally, one thing I want to call out is that the allocation guideline, that is totally up to you as to how you want to stake your bets. Typically the 70-20-10 is just our kind of general guideline, but it's up to you as to how you want to go about doing that. And then that kind of falls into the aspects of our risk budgeting and what that plays into overall. Typically, we also review the allocation periodically. If times are tough, maybe we lean more on H1. If we are flush and fear of disruption, maybe we increase bets on H3. So, and then this is just kind of a high guideline of the various different stages of those gates, what are kind of checklist aspects, things that you need with each one of those gates, and additionally other artifacts to kind of keep in mind as part of the end goal for the aspects of what you're providing for your executive dashboard or your board dashboard. And then this is just kind of a breakdown of the fusion of the various types of teams, typically product owner and engineering lead, security, privacy, a finance partner, ops and SRE, domain SME, and then change management individuals. So just things to kind of keep in mind inside of this aspect for building the fusion team and how to move fast with those different types of projects. You can either bring a team like us in that do all of this, and we partner with a lot of your own business to do this, or typically we can help you build that team as well to help it allow you to do this more freely on your own. Additionally, the dual speed governance, this kind of just touches on the aspects of allowing us to move fast, but also staying safe, making sure we avoid the whole aspects of the innovation theater, which effectively is the aspects of what typically a lot of places will do. They'll have hackathons or a lot of POCs driven, but nothing actually comes out of it. They never actually fully take anything to production and never gets past that pilot stage effectively. And so that can really hinder your ability for a company to innovate and become better. And so the big thing here is making sure that you move forward to the next stage. And one of the big things that can actually help that is governance, making sure that you set clear limits and boxes and define them and allow for innovation to thrive within inside of their bounds, and allows you to grow fast and actually get to that next stage. Typically, it's split up into different two areas: dev, innovation sandbox, and then your production environment, which typically requires some sort of change advisory board for approvals. But effectively, these two work hand in hand to effectively allow for innovation to go forward. So like dual speed governance ensures innovation, which isn't strangled by the same process as like a core banking system change that would be too slow, but also ensures that when innovation touches real business, it goes through proper checks effectively. And so lastly, I'm kind of running through the last part of these slides, but this is just a really good 90-day plan. This is typically what we take a lot of our clients through and saying, okay, here's the next 90 days for this. Here's the first 30. Here's how we got to build this up, found the foundations and move forward, how we run pilots, and then finally getting to that scale and build out aspects. And what does that look like? And so this just really allows us to provide clear markers as to, for our clients, as to how do you do adoption of a bleeding edge technology effectively. And then board level summary. This is just honestly a section that allows for you to understand and display to your board or executive staff that says, hey, here are the valid aspects of what is actually being transformed and how we move forward, and presents different ways to keep the board engaged and confident that the innovation management is effectively actually like a portfolio and not just a black hole for where money goes and nothing comes out of it. Lastly, we do have a workshop that we have that runs around 3 to 4 hours that kind of we walk you through this process with any ideas that you may have and help you get to that point to effectively get you through bleeding edge technology, whether that's quantum, AI, ML, or kind of any other major technologies that are out there that are starting to be innovated on. So that being said, Q&A, I tried to leave some time. I think I got like 4 minutes here. So
Do companies start with a campaign to solicit ideas?
yes, that is honestly a really good way to do that. That's kind of where I've come from a couple other companies as well that have done this, where they have just a public forum where it's a website that they go to submit ideas, and they kind of do this kind of innovation loop that they go through and make sure they understand aspects about it to kind of bring ideas to the table. But yes, typically I've seen positive results where the company will start a website that does just collection of those ideas and marks his who brought that idea to the table, how would they get that started, or how to move them, effectively establishing a champion up front.
Thank you all for attending today's Improving Talk. And Scott, thank you for sharing the incredibly hot webinar titled Executive Playbook on Integrating Bleeding Edge Tech. The recording of this session will be available next business day. To view the recording, locate the session from Improving's virtual events page, where you can also register for future events, for future improving events. We hope you all have a wonderful week, and thank you.
Thank you.